Hello there, and welcome to the Dreamy Ocean Channel. Perhaps the day has been long, its demands echoing softly in your mind, or maybe a quiet restlessness still stirs within. Whatever the day has held, know that this moment is for you, a gentle pause. Take a moment now to let those echoes fade, to soften the edges of your thoughts. Unclench your jaw, release any tension from your brow, and allow your shoulders to gently drop, feeling the comfortable weight of your body settling, becoming heavier, softer with each passing breath. Breathe in slowly, deeply, drawing calm into your being, and as you exhale, imagine any lingering worries, any small stresses simply drifting away, like wisps of mist on a calm, moonlit horizon. Tonight, we journey into the boundless blue to meet a creature so profoundly strange, so uniquely shaped by the ocean's vastness. It appears almost as a celestial body adrift in the deep, the ocean sunfish, a living marvel that seems to be nothing but a colossal head, swimming through the currents, the world's heaviest bony fish. Allow your mind to gently detach, to float into these serene, deep waters as we begin to explore its quiet, wondrous mysteries. The enigma of the Mola. Within the silent, shimmering expanse of the global ocean, where sunlight filters down through countless fathoms of blue, there drifts a creature of such profound and singular form that its very existence seems to defy the familiar contours of life itself. This is the ocean sunfish, known to science as Mola, a name whispered across the waves, often evoking a quiet sense of wonder, sometimes even a touch of bewildered fascination. It is a being sculpted by the slow, immense forces of the deep, a living enigma that glides through the currents, a colossal, flattened disc of bone and muscle that appears at first glance as if a cosmic artist began to sculpt a fish, then paused, leaving only a magnificent truncated head, propelled by fins that seem almost an afterthought. Imagine, if you will, a vast circular shadow materializing from the hazy depths, slowly resolving into a form unlike any other you have ever encountered. This is not a sleek torpedo-shaped predator, nor a delicate reef-dwelling marvel. Instead, it is a truly immense presence, a living wall of silver grey, often mottled with hues of brown or white. Its skin rough and leathery, sometimes bearing the scars of its journey through the ocean's vastness. With an average adult weight that can easily surpass 1 metric ton and specimens recorded weighing over 2,000 kilograms, this creature holds the undisputed title as the heaviest known bony fish on our planet. To put this into perspective, imagine the combined weight of several small cars, or a fully grown rhinoceros compressed and flattened into an oval disc, silently navigating the ocean's liquid skies. Its sheer scale is an immediate and profound statement, a declaration of its mastery over a unique biological niche. Yet it is a mastery expressed not through speed or aggression, but through an almost ethereal, unhurried grace. The name Mola itself, derived from the Latin word for millstone, perfectly captures its round, grey and textured appearance, a fitting descriptor for a creature that seems to have been carved from an ancient geological process rather than born of biological evolution. Yet it is also known as the ocean sunfish, a poetic moniker that hints at one of its most observed and perhaps most endearing behaviors, its tendency to bask near the surface, lying flat on its side, seemingly soaking in the warm embrace of the sun's rays. This behavior, observed across countless oceans, adds another layer to its mystique, painting a picture of a giant, ancient being finding solace and warmth in the sun-drenched upper layers of its vast, cold home. It is a moment of quiet communion between the immense ocean and the distant star that nourishes all life, a silent, slow ritual performed by a creature that seems to exist on the very edge of our understanding. The enigma of the Mola is not merely in its size or its peculiar shape, but in the profound questions it raises, questions that resonate with the very depths of our curiosity about life on Earth. How does such a creature survive, even thrive with a form that appears so inherently awkward, so seemingly inefficient? Its body ends abruptly, almost as if its posterior half has been surgically removed, leaving behind a broad rudder-like clavus instead of a true caudal fin. This unique morphology, which we will gently explore in more detail, makes it appear as if it is perpetually swimming with only half a body, a living paradox that glides through the water with an undulating motion of its dorsal and anal fins, creating an impression of slow, rhythmic flight rather than typical fish propulsion. This truncated form is not a flaw, however, but a testament to millions of years of specialized evolution, a design perfected for its specific way of life, a silent testament to the ocean's boundless creativity. Despite its immense size, the ocean sunfish remains a creature shrouded in a captivating aura of mystery. It is not an animal frequently encountered by casual observers, preferring the vast open expanses of the pelagic zone, the blue desert of the world's oceans. From the temperate waters of the Atlantic and Pacific to the warm currents of the Indian Ocean, the Mola drifts a nomadic giant whose movements are often dictated by the subtle shifts in water temperature and the availability of its preferred gelatinous prey. This global distribution, coupled with its elusive nature, means that much about its daily life, its intricate behaviors and its precise migratory patterns remain largely undiscovered, hidden within the oceanic depths. Scientists, with their patient observations and advanced tracking technologies, are slowly, carefully piecing together the fragments of its story. But each new discovery often unveils a fresh layer of questions, deepening the quiet intrigue that surrounds this magnificent fish. The very essence of the Mola seems to whisper of ancient times, of a world less explored, less understood. It carries within its massive flattened form the echoes of geological ages, a living fossil of adaptation that has perfected a unique existence in the boundless blue. Its presence in the water is often described as serene, almost dreamlike, a slow-moving monument to the ocean's enduring secrets. Encountering an ocean sunfish, whether in person or through the lens of a camera, is often a deeply humbling experience, a gentle reminder of the extraordinary diversity that flourishes beneath the waves and of the many wonders that still await our quiet contemplation. As we prepare to gently unfurl the layers of its existence, allowing our minds to drift alongside this colossal, enigmatic being, we begin to understand that the true marvel of the Mola lies not just in its physical peculiarities, but in the profound sense of wonder and curiosity. It inspires a silent invitation to explore the quiet mysteries of our shared planet. Let us now gently descend further, allowing the soft currents of knowledge to carry us toward a deeper understanding of this remarkable creature. A body without a tail. The anatomy of extremes. As the gentle currents of our exploration carry us deeper, we find ourselves drawn into the very architecture of the ocean sunfish, a structure so profoundly divergent from the typical fish form that it compels a quiet contemplation. Its most striking feature, the one that immediately captures the eye and provokes a soft sense of bewilderment, is its profound lack of a true caudal fin or tail. Instead of the powerful horizontally sweeping propeller found on most marine inhabitants, the Mola concludes its immense flattened body with a unique scalloped fringe known as the clavus. This structure, a testament to millions of years of specialized evolution, is not a tail in the conventional sense, but a modified dorsal and anal fin race structure fused and reshaped, creating an undulating living rudder that completes its disc-like silhouette. Imagine running your hand ever so gently along the edge of a colossal living plate. The clavus would feel leathery firm yet flexible, its edges often appearing tattered or irregular, a visual signature of its journey through the immense ocean. It is a slow, rippling border, providing stability and subtle directional control, but utterly incapable of the explosive bursts of speed that a true caudal fin might deliver. This absence of a powerful tail speaks volumes about the Mola's lifestyle. It is not a hunter that chases its prey with sudden, rapid acceleration, nor is it a creature built for swift escape. Instead, its propulsion is a marvel of gentle, synchronized power, stemming almost entirely from the magnificent wing-like fins that extend vertically from its dorsal and ventral surfaces. These two immense fins, the dorsal fin reaching skyward and the anal fin mirroring it directly below, are the primary engines of the ocean sunfish. They are colossal triangular sails of muscle and cartilage, often as tall as the fish's own body depth, giving the entire creature an appearance of great height and presence as it glides through the water. Picture them undulating slowly, almost hypnotically, in perfect opposition, one rising as the other falls, creating a rhythmic sculling motion that propels the massive body forward with a quiet, persistent grace. It is a slow, elegant ballet of biological mechanics, a continuous wave-like movement that allows the Mola to drift effortlessly through the vastness, its progress unhurried yet unstoppable. This synchronized oscillation, a silent, powerful pulse, allows for a precise control over its depth and direction. A languid flight through the liquid world more akin to a bird soaring on thermal currents than a fish swimming with powerful kicks. Contrasting sharply with the grandeur of its dorsal and anal fins are its pectoral fins positioned just behind its small, almost purse-like mouth. These fins are remarkably diminutive, almost vestigial, resembling tiny, round, paddle-like appendages that seem to perform little more than subtle adjustments to its orientation. They are not used for propulsion, nor for significant steering, further emphasizing the specialized role of the larger vertical fins. Their small size is another clue to the Mola's evolutionary path, suggesting a reduction in their importance as the dorsal and anal fins assume the primary role of movement. This anatomical choice allows for the massive flattened body plan, minimizing drag from unnecessary appendages and streamlining its unique form for its particular mode of slow, purposeful drift. Turning our attention to the Mola's head, we find a small, puckered mouth surprisingly delicate for an animal of such immense proportions. It is armed with a unique fused beak-like structure, a dental plate that lacks individual teeth. This specialized mouth is perfectly adapted for its primary diet of soft-bodied gelatinous zooplankton, particularly jellyfish and salps. Imagine the gentle suction required to draw in a pulsating diaphanous jellyfish, or the delicate tearing needed to consume a string of salps. The small mouth, far from being a limitation, is an exquisitely refined tool for its specific foraging strategy, allowing it to consume its often ephemeral prey with quiet efficiency, without expending excessive energy in pursuit or capture. The skin of the ocean sunfish is another remarkable feature, a rough, leathery expanse often devoid of the smooth, iridescent scales found on many fish. Instead, it is thick and resilient, with a texture that can range from finely granular to quite coarse, sometimes even bearing small, bony protuberances, adding to its ancient, almost prehistoric appearance. This robust integument serves as a vital protective layer, a shield against the abrasive forces of the ocean, and a canvas upon which the stories of its life are subtly etched. It is also a favored habitat for a diverse array of parasites, from copepods to trematodes, which often cling to its surface. This abundance of external passengers is believed by scientists to be one of the reasons for its frequent basking behavior at the surface, where it is thought to invite seabirds such as gulls to pick off these unwelcome guests, or to seek out cleaner fish in shallower waters, engaging in a silent, symbiotic exchange. Beneath this distinctive skin lies a skeleton that presents another fascinating paradox. Despite being classified as the heaviest bony fish, the Mola's internal framework is largely cartilaginous, particularly in its vertebral column, which is significantly reduced and simplified compared to other large fish. This lighter, more flexible skeletal structure allows for its immense size to be achieved without the prohibitive weight of a fully ossified skeleton, aiding in buoyancy control and allowing for its characteristic slow, undulating movements. The bones it does possess are spongy and lightweight, a clever evolutionary compromise that enables its colossal dimensions while maintaining a degree of neutral buoyancy, allowing it to effortlessly suspend itself in the water column without expending vast amounts of energy to stay afloat. It is a testament to the fact that evolution often finds the most unexpected and elegant solutions to the challenges of existence. Delving deeper into the internal landscape of this gentle giant, we discover that its brain is remarkably small in proportion to its immense body, often no larger than a walnut, a feature that has long fascinated and puzzled researchers. This tiny neural command center, embedded within a colossal frame, suggests a creature whose life is driven more by instinct and environmental cues than complex cognitive processes. Its internal organs are also relatively compact, nestled within the vast, flattened cavity of its body, leaving ample space for the tissues that contribute to its buoyancy and support its slow, deliberate movements. Notably, the Mola lacks a swim bladder, the gas-filled organ that most bony fish use to regulate their buoyancy. This absence is another clue to its unique adaptation, suggesting that its buoyancy is instead managed through the composition of its tissues, particularly its jelly-like subcutaneous layer, which is less dense than seawater, allowing it to maintain its position in the water column with minimal effort. Its gills, the intricate respiratory structures that extract life-giving oxygen from the water, are highly efficient, designed to process the large volumes of water that flow past its slow-moving form. As the Mola glides, water gently enters its small mouth and passes over the feathery gill filaments where oxygen is absorbed into its blood, fueling its immense yet unhurried existence. The eyes, though relatively small compared to its overall size, are positioned on the sides of its head, providing a wide field of vision, crucial for a pelagic creature that must scan the vastness for its dispersed prey and potential threats. And like many fish, it possesses a lateral line system, a faint, almost invisible sensory array running along its flanks, which detects subtle pressure changes and vibrations in the water, allowing it to perceive its environment even in the dim light of the deep, a silent sonar guiding its ponderous journey. Each anatomical detail, from the peculiar clavus to the tiny brain, from the leathery skin to the cartilaginous skeleton, contributes to the profound uniqueness of the ocean sunfish. It is a creature of extremes, a living sculpture of adaptation that has perfected a life of gentle drift and specialized feeding in the boundless, ever-shifting currents of the open ocean. Its form is not a haphazard collection of parts, but a meticulously evolved system, a testament to the myriad ways life can flourish and find its place even in the most challenging and expansive environments. As we allow these images of its extraordinary structure to settle softly in our minds, we begin to appreciate the quiet genius of its design, a design that allows it to exist as the world's heaviest bony fish, a colossal yet gentle enigma of the deep. Deep time drifters, the evolutionary path of the sunfish. Having gently explored the extraordinary anatomy of the ocean sunfish, we now allow our minds to drift further back in time, tracing the silent, immense arc of its evolutionary journey, a path sculpted over countless millennia by the patient, relentless hand of natural selection. The story of the Mola is not a singular, isolated narrative, but a profound chapter within the grander epic of bony fish, a lineage that first emerged from the primordial waters hundreds of millions of years ago, spreading its myriad forms across every aquatic realm. Our journey begins not with the familiar disc-like silhouette of the sunfish, but with a family of fish that at first glance might seem quite different, the tetraodontiforms. This ancient order to which the Mola belongs encompasses a fascinating array of creatures, including the puffers, the triggerfish, the boxfish, and the filefish. Imagine these distant cousins, often characterized by their tough, leathery skin, their powerful, fused beak-like teeth, and their unique adaptations for defense, such as the ability to inflate their bodies or deploy sharp spines. These shared ancestral traits, subtle whispers from their common heritage, hint at the deep evolutionary roots that connect the ponderous sunfish to its more compact, often more pugnacious relatives. From this diverse and ancient lineage, a specific branch began to diverge, embarking upon a truly remarkable evolutionary experiment. Scientists believe that the ancestors of the Molidae family, the sunfish, gradually shifted from a more reef-associated or benthic existence, where the ability to maneuver quickly in complex environments or to defend territory was paramount, towards an increasingly pelagic, open ocean life. This shift in habitat brought with it entirely new, selective pressures, favoring adaptations that would optimize survival in the vast, featureless blue, where food might be scarce and predators could appear from any direction. One of the most profound transformations along this evolutionary path was the gradual, almost imperceptible reduction and eventual loss of the caudal fin, the powerful tail that defines the propulsion of most fish. Over geological epochs, the ancestral caudal fin, once a vital engine for rapid bursts of speed, began to shrink, to flatten, to reabsorb its bony rays, slowly being replaced by the unique, non-propulsive clavus. This was not a sudden dramatic mutation, but an accumulation of countless tiny adjustments, each favored by natural selection, because it conferred a slight advantage in the sunfish's evolving niche. Perhaps the ancestral forms found less need for bursts of speed, relying instead on a more energy-efficient, continuous mode of locomotion, or perhaps the reduction of the tail allowed for a greater emphasis on other forms of defense or buoyancy control. As the caudal fin diminished, the dorsal and anal fins, once supplementary stabilizers, began to assume a dramatically expanded role. Imagine these fins growing larger and more muscular with each passing generation, slowly transforming into the colossal wing-like structures we observe today. These fins became the primary engines of propulsion, their rhythmic, synchronized undulations offering a continuous low-energy method of movement, perfectly suited for drifting through the open ocean. This evolutionary trade-off, sacrificing burst speed for sustained, energy-efficient locomotion, is a hallmark of the Mola's success in its pelagic environment, allowing it to cover vast distances without the need for constant demanding bursts of anaerobic energy. Simultaneously, the body plan itself underwent a radical metamorphosis. From a more typical fusiform fish shape, the sunfish lineage began to flatten, laterally expanding into the distinctive compressed disc that defines its modern form. This extreme flattening, reminiscent of a colossal pancake or a living millstone, is believed by scientists to have several adaptive benefits. It presents a formidable profile to potential predators, making the immense creature appear even larger and more unwieldy to consume. It also aids in thermoregulation, allowing the sunfish to absorb warmth more efficiently when basking at the surface, a crucial behavior for a creature that often dives into frigid, deep waters to feed. Furthermore, this flattened shape, combined with its unique propulsion, may offer hydrodynamic advantages for slow, sustained gliding through the water column, minimizing drag for its particular style of movement. The evolution of its specialized mouth and diet is another critical chapter in the Mola's deep time story. While many of its tetraodontiform relatives possess powerful jaws and teeth for crushing shells or scraping algae, the sunfish developed a small, puckered mouth with fused beak-like dental plates perfectly adapted for consuming soft-bodied gelatinous zooplankton. This shift towards a diet of jellyfish salps and other diaphanous organisms suggests a profound ecological specialization. In the open ocean, these gelatinous creatures, though often low in nutritional density, are frequently abundant, forming vast dispersed aggregations. The sunfish's mouth therefore evolved not for force, but for gentle, efficient suction and manipulation of these delicate prey items, a testament to its commitment to this specific energy-efficient foraging strategy. The internal architecture of the Mola also bears the marks of this long evolutionary journey. The reduction of its skeletal ossification, leading to a largely cartilaginous and lightweight bone structure, is a significant adaptation. Unlike many heavy, bony fish that rely on a large gas-filled swim bladder for buoyancy, the sunfish manages its buoyancy through the composition of its tissues, particularly a thick, jelly-like subcutaneous layer that is less dense than seawater. This evolutionary innovation, the reduction of heavy bone mass, and the reliance on buoyant tissue allows the Mola to achieve its colossal size without becoming a dense, sinking mass, enabling it to drift effortlessly through the water column with minimal energy expenditure. This solution to the challenge of buoyancy is an elegant and powerful example of convergent evolution, where different lineages arrive at similar functional outcomes through distinct biological pathways. The thick, leathery, and often rough skin of the sunfish, too, is an evolutionary legacy. While it serves as a robust protective barrier against the physical stresses of the open ocean, it also reflects a shared trait with its pufferfish relatives, many of whom possess similarly tough integuments, sometimes adorned with spines. This tough skin, though a magnet for parasites, has likely offered a significant defensive advantage against predators throughout its evolutionary history, making the Mola a less appealing or difficult meal for larger, more powerful oceanic hunters. The fossil record for the Molidae family is, like the creature itself, somewhat enigmatic. Due to the largely cartilaginous nature of its skeleton, sunfish fossils are exceedingly rare and often incomplete, making the direct tracing of its evolutionary lineage a challenging endeavor. However, paleontological evidence coupled with comparative anatomical and genetic studies of living tetraodontiforms allows scientists to reconstruct a plausible evolutionary narrative. The earliest known fossil evidence of Molidae-like forms dates back to the Eocene epoch, roughly 40 to 50 million years ago, indicating that this unique body plan has been a successful strategy for a very long time, enduring through significant shifts in Earth's climate and oceanic conditions. The very existence of the Mola stands as a profound testament to the boundless creativity of evolution, a slow, patient sculptor that has carved this magnificent, bizarre form from the raw materials of life. It is a creature that has honed its existence to an extreme degree, shedding what was unnecessary, expanding what was advantageous, all in response to the subtle, persistent whispers of its environment. Its journey through deep time is a story of adaptation, of specialization, of finding an utterly unique way to thrive in the world's largest habitat. As we allow these ancient echoes to resonate within our quiet minds, we gain a deeper appreciation for the long, winding path that led to the emergence of this ponderous yet profoundly elegant deep time drifter, navigating the blue expanse, global habitats and migrations. From the ancient currents that shaped its form, we now follow the ocean sunfish as it embarks upon its silent, ceaseless journey across the world's immense aquatic canvas, navigating the vast blue expanse of its global home. The Mola is a true wanderer of the pelagic zone, the open ocean, a realm without fixed landmarks where the only discernible features are the shifting patterns of light temperature and the invisible pathways of oceanic currents. Its presence graces temperate and tropical waters across the entire globe, from the sun-kissed surfaces of the Pacific and Atlantic to the warm, embracing swells of the Indian Ocean, often venturing into the cooler yet still hospitable fringes of the Southern Ocean. It is a cosmopolitan giant seemingly at home in any ocean that offers the right blend of thermal comfort and abundant, gelatinous sustenance. Imagine standing on a high cliff, gazing out at an ocean that stretches infinitely to the horizon, a boundless blue desert beneath an endless sky. Within this immense liquid wilderness, the Mola drifts a living island of flesh and bone, perfectly adapted to a life of perpetual motion, without fixed abode. Unlike fish that cling to the vibrant, complex ecosystems of coral reefs or the structured environments of continental shelves, the sunfish thrives in the seemingly featureless void, where light filters down from above and the depths plunge into an eternal twilight. This pelagic existence dictates much of its behavior, its diet, and its very survival, compelling it to follow the subtle whispers of the ocean, moving with the great gyres and currents that endlessly circulate the planet's waters. One of the most iconic behaviors of the ocean sunfish, and indeed the source of its common name, is its tendency to bask near the surface, lying flat on its side, often with its colossal dorsal fin breaking the water's shimmering plane. Picture this immense disk, slowly rotating, allowing the sun's gentle warmth to permeate its thick, leathery skin. Scientists believe this sunbathing ritual serves several crucial purposes. Firstly, it is a vital act of thermoregulation. The sunfish frequently undertakes deep, prolonged dives into the frigid abyssal waters in pursuit of its prey, where temperatures can plummet dramatically. Returning to the surface allows its vast body to slowly re-warm, absorbing solar energy into its core, revitalizing its metabolic processes after the chill of the deep. It is a slow, deliberate absorption of solar warmth, a silent rebalancing of its internal temperature, preparing it for the next descent into the cold, dark world below. Beyond thermoregulation, this surface basking is also thought to be a strategic maneuver for parasite removal. The mola's rough skin is a favored habitat for a diverse array of external parasites, from tiny copepods to larger trematodes which cling tenaciously to its surface. By lying exposed at the surface, the sunfish effectively invites seabirds, such as gulls and petrels, to gently alight upon its broad back and meticulously pluck away these unwelcome guests. A remarkable example of interspecies cooperation in the wild. Furthermore, in coastal areas where they sometimes venture, sunfish have been observed seeking out cleaner stations. Specific locations where smaller, cleaner fish like rasa will swarm over their bodies, delicately removing parasites from their skin gills and even their small, puckered mouths. These moments of quiet vulnerability, where the giant submits to the ministrations of much smaller creatures, paint a picture of an animal deeply integrated into the complex web of marine life, despite its solitary wanderings. Yet the sunfish is not solely a creature of the sunlit surface. Its life is a constant, slow, vertical migration, a rhythmic ascent and descent through the water column. Driven by the relentless quest for food, these colossal fish undertake astonishing deep dives, plunging hundreds of meters, sometimes even exceeding 800 meters into the mesopelagic and bathypelagic zones. Imagine the gradual fading of light as it descends the vibrant blues, giving way to an ethereal indigo, then to a profound inky blackness, punctuated only by the faint bioluminescent flickers of deep-sea organisms. In these cold, pressurized depths, the Mola seeks out vast aggregations of jellyfish, siphonophores, and salps its primary food sources. Its small, specialized mouth, so perfectly adapted for delicate suction, allows it to consume these soft-bodied creatures with quiet efficiency, its immense body drifting through the silent gloom, a colossal shadow against the deeper darkness. These vertical migrations are not random. Scientists utilizing advanced satellite tagging technology have begun to unravel the intricate patterns of the sunfish's movements. By attaching small pressure and temperature-sensitive tags to their dorsal fins, researchers can track the sunfish's precise depth temperature exposure and geographical location over extended periods. These data reveal a consistent pattern. Multiple deep dives throughout the day interspersed with periods of surface basking. The duration and depth of these dives are often influenced by the time of day, with deeper, longer dives occurring during daylight hours, perhaps to avoid surface predators, or to access deeper dwelling prey, followed by a return to warmer surface waters for recovery and rewarming. Geographical migrations, though less understood than their daily vertical movements, are also a significant aspect of the Mola's life. While specific large-scale migrations akin to those of whales or tuna are not yet fully documented, satellite tag data have shown individual sunfish covering vast distances across entire ocean basins. Some individuals have been tracked traveling thousands of kilometers, drifting with the great oceanic currents from the coasts of California to the waters off Japan, or from the shores of Europe into the open Atlantic. These immense journeys are believed to be driven by a combination of factors: the search for abundant food sources, which can be highly localized and seasonal, and the pursuit of optimal water temperatures. The Mola is highly sensitive to cold water, and prolonged exposure to temperatures below 12 degrees Celsius can be lethal. Thus, their movements are often a slow, deliberate dance with the isotherms, the invisible lines of equal temperature that crisscross the ocean. The influence of oceanic currents on the Mola's distribution and movement cannot be overstated. These colossal fish, with their ponderous sculling propulsion, are not built for fighting strong currents. Instead, they are master drifters, allowing the powerful, ceaseless flow of the ocean to carry them across vast distances, conserving energy while subtly adjusting their course with the rhythmic undulations of their dorsal and anal fins. Imagine a vast living kite catching the invisible winds of the ocean, its trajectory guided by forces far greater than its own propulsion. This passive mode of transport allows them to exploit geographically dispersed food patches and to move between different regions without expending the immense energy that more actively swimming fish would require. While primarily creatures of the open ocean Mola are occasionally observed closer to shore, particularly in temperate regions where upwelling currents bring nutrient-rich waters and aggregations of jellyfish. These coastal forays are often temporary, perhaps driven by the lure of abundant food or the need to visit cleaner stations, found in shallower, more sheltered environments. Their appearance near land, however, is often a rare and memorable event for divers and boaters, offering a fleeting glimpse into the mysterious lives of these pelagic giants. The sheer scale of the Mola's habitat, encompassing the majority of the world's oceans, speaks to its incredible adaptability and evolutionary success. It is a creature that has found its niche in the seemingly empty spaces, thriving where other forms of life might struggle. Its life is a perpetual journey, a slow, deliberate navigation of the blue expanse guided by the sun's warmth, the ocean's currents, and the whispered promise of food in the depths. As we allow these images of its global wanderings to gently settle in our minds, we begin to appreciate the silent, immense scope of its existence, a colossal drifter forever at home in the boundless, ever-shifting liquid world. The jellyfish feast, diet and specialized foraging. As the sunfish gently navigates the vast blue expanse, its immense flattened form becomes a silent testament to a truly specialized way of life, particularly evident in its remarkable diet and the subtle art of its foraging. For a creature that can weigh as much as a small car, one might expect a diet of powerful, swift-moving prey, perhaps schools of tuna or large, robust squid. Yet the Mola sustains its colossal bulk on a diet that at first glance seems utterly improbable. The ephemeral, gelatinous denizens of the deep, primarily jellyfish, salps and siphonophores. This is the heart of the jellyfish paradox. A quiet marvel of biological adaptation that allows a 2-ton animal to thrive on organisms composed mostly of water, offering scant nutritional density. Imagine the ocean's twilight zone where sunlight becomes a faint, ethereal glow, barely illuminating the water. Here, vast aggregations of translucent bells and trailing tentacles drift with the currents, each a pulsating diaphanous entity, some trailing delicate stinging filaments, others forming intricate colonial chains. These are the jellyfish, the primary sustenance for the ocean sunfish. They are silent, slow-moving, and often form immense dispersed blooms, presenting a unique challenge and opportunity for a specialized predator. The Mola does not chase its food with bursts of speed. Instead, it drifts a colossal living sieve, slowly moving through these gelatinous gardens, allowing its prey to be encountered rather than pursued. Its mouth, as we have softly observed, is a small, puckered aperture, almost avian in its appearance, a stark contrast to the gaping maw of many large marine predators. This is not a mouth built for tearing through tough flesh or crushing bone. Instead, it is exquisitely adapted for a diet of soft-bodied organisms. The fused beak-like dental plates within its mouth act as a gentle yet effective tool for grasping and shearing the delicate tissues of jellyfish and salps. Picture the sunfish slowly approaching a large bell-shaped jellyfish, its immense body almost dwarfing its prey. With a subtle, controlled movement of its head and the gentle puckering of its mouth, it creates a slight suction, drawing the gelatinous creature inward. The fused plates then work to snip away sections of the jellyfish, allowing the sunfish to ingest its meal piece by delicate piece. It is a slow, methodical process, a testament to efficiency over brute force. The sheer volume of food required to sustain a 2-ton body on a diet so lacking in calories is staggering. Scientists believe that a single adult Mola must consume an immense quantity of gelatinous zooplankton daily, perhaps hundreds of kilograms, to meet its metabolic demands. This constant, voracious yet seemingly effortless consumption drives much of its behavior, particularly its deep, rhythmic, vertical migrations. As the sunfish descends into the colder, darker depths, sometimes plunging beyond 800 meters, it enters the realm where many of these gelatinous organisms aggregate. The deep ocean, with its stable temperatures and lack of strong currents, provides a relatively undisturbed habitat for these often fragile creatures, forming vast, dispersed feeding grounds for the sunfish. These dives are not random excursions. Researchers employing advanced acoustic and satellite tags have discovered a consistent pattern in the sunfish's foraging strategy. They undertake multiple deep dives throughout the day, often spending significant periods at depth, meticulously sweeping through the water column to locate and consume their dispersed prey. Imagine the immense creature, a silver-grey disc, silently gliding through the perpetual twilight, its small eyes scanning the dimness, its lateral line system subtly detecting the faint pressure waves generated by the slow pulsations of a jellyfish bell. It is a slow-motion hunt, a ballet of gentle detection and deliberate ingestion, where patience and persistence are the key tools. Once its stomach is full, or perhaps when the chill of the deep becomes too profound, the sunfish slowly ascends, rising towards the sunlit surface. This ascent is not merely a return to warmer waters, but a crucial part of its foraging cycle. The warmth absorbed during its surface basking periods, which we discussed earlier, is vital for re-energizing its metabolic processes after the cold, energy-intensive dives. It is a delicate balance between the deep, cold feeding grounds and the warm, restorative embrace of the sun-drenched surface, a rhythmic dance with the ocean's thermal layers, all in service of processing and digesting its low-calorie, high-volume meals. While jellyfish salps and siphonophores form the overwhelming majority of the mola's diet, opportunistic feeding on other soft-bodied organisms has been observed. This might include small larval fish, tiny crustaceans that drift passively in the water column, or even small squid. These supplementary items, however, are believed to be incidental or occasional additions, perhaps encountered during its slow drifts rather than actively pursued. The fundamental design of its mouth and digestive system remains optimized for the consumption of gelatinous prey, a testament to its deep evolutionary commitment to this specific ecological niche. The success of the Mola in sustaining its colossal size on such a seemingly insubstantial diet lies in a combination of factors all interconnected. Its slow, deliberate movements, propelled by the gentle undulations of its dorsal and anal fins, require relatively little energy compared to the powerful swimming of other large fish. Its largely cartilaginous skeleton and buoyant jelly-like subcutaneous tissues further reduce its energy expenditure for buoyancy control, allowing it to remain suspended in the water column with minimal effort. This low metabolic rate, coupled with its ability to efficiently process vast quantities of water-rich food, creates a sustainable balance for its existence. It is a marvel of energy conservation, a living embodiment of the principle that less can indeed be more, especially when it comes to the expenditure of precious energy in the vast, often resource-scarce open ocean. The ecological role of the ocean sunfish, while not fully understood, is undoubtedly significant, particularly in regions where jellyfish blooms are prevalent. By consuming vast quantities of these gelatinous organisms, the Mola acts as a natural control, helping to regulate jellyfish populations. In an era where human activities are increasingly impacting marine ecosystems, sometimes leading to an increase in jellyfish blooms, the sunfish's role as a key predator of these organisms becomes even more critical, contributing to the delicate balance of the pelagic food web. It is a quiet yet powerful force in the ocean's intricate ecosystem, a colossal gardener tending to the vast sprawling gardens of gelatinous life. Observing the Mola feeding in its natural habitat is a rare and challenging endeavor for scientists. Its pelagic nature, its deep diving habits, and its often solitary existence make direct observation difficult. Much of what we understand about its diet comes from stomach content analysis of stranded or incidentally caught specimens, combined with the insights gained from tracking data that correlates its movements with known aggregations of gelatinous prey. Each piece of evidence, each fragment of observation, slowly contributes to a more complete picture of this enigmatic feeder, revealing the quiet ingenuity of its specialized foraging strategy. As we allow our minds to gently envision this immense creature, silently consuming its ethereal meals in the ocean's vastness, we are reminded once again of the boundless diversity of life and the intricate ways in which organisms adapt to their environments. The Mola's jellyfish feast is not just a biological process. It is a profound story of evolutionary success, a testament to how even the most seemingly improbable diets can sustain the most colossal of beings, allowing them to drift ponderous and serene through the limitless blue. From microscopic star to oceanic giant, the life cycle marvel. Having gently observed the silent mechanics of the sunfish's specialized foraging, we now turn our gaze to an even more profound marvel: the extraordinary journey of its life cycle, a transformation that begins from a speck almost invisible to the human eye and culminates in the immense 2-ton drifter of the open ocean. This is a story of astronomical growth, of radical metamorphosis, and of an almost improbable survival against the relentless forces of the deep. The genesis of an ocean sunfish begins with a prodigious act of reproduction, a biological strategy designed to overcome the immense perils of the pelagic realm. The female Mola holds the undisputed record among all known vertebrates for producing the largest number of eggs. Imagine, if you can, a single individual releasing an astonishing bounty of up to 300 million eggs into the vast, indifferent ocean. This colossal output is not a wasteful extravagance, but a stark necessity, a testament to the infinitesimally small chances of survival for each individual egg and the fragile larval forms that emerge. These eggs, microscopic spheres of nascent life, are released into the open water, buoyant and adrift, entrusted to the capricious currents, destined to become part of the great planktonic soup that drifts across the world's oceans. Each of these countless eggs is a tiny translucent speck, a mere fraction of a millimeter in diameter, almost perfectly spherical, carrying within its delicate membrane the genetic blueprint for a future giant. They are pelagic eggs, meaning they float freely in the upper layers of the ocean, warmed by the sun, gently carried by the ceaseless flow of the currents. Here, in this immense liquid nursery, they are utterly vulnerable, subject to the hungry mouths of myriad filter feeders and opportunistic predators, to the harsh fluctuations of temperature, and to the sheer, overwhelming vastness of their surroundings. the chances of any single egg developing into a viable larva, let alone reaching maturity, are astronomically slim, yet it is this sheer, overwhelming quantity that ensures the continuation of the species. From this microscopic beginning, a truly wondrous transformation unfolds. Upon hatching, the Mola larva emerges as a creature of such delicate beauty and profound difference from its adult form that it is almost unrecognizable. Imagine a tiny, almost perfectly spherical body no larger than a pinhead, adorned with an array of sharp, radiating spines that protrude outward like the rays of a miniature living star. These larval sunfish, sometimes called spiny mola, are miniature marvels, their bodies covered in these intricate bony protuberances that serve as a crucial defense mechanism against the countless small predators that populate the planktonic world. Picture them drifting almost imperceptibly through the sunlit upper layers, their tiny fins gently fluttering, each spine a silent declaration of their struggle for survival. These early larval stages are a period of extreme vulnerability and intense competition. They subsist on microscopic plankton, tiny diatoms and copepods, themselves drifting within the same currents. The rapid growth and metamorphosis of these larvae are critical for their survival. As they grow, they begin to shed their protective spines, a gradual process that marks their transition towards a more recognizable sunfish form. The spherical body begins to elongate slightly, the tiny dorsal and anal fins, mere nubs, at first start to develop and grow, slowly taking on the characteristic wing-like shape that will define their adult propulsion. This transition from a spiky, star-like form to a more flattened, disc-shaped body is a testament to the efficiency of evolution, shedding unnecessary structures as the creature grows and its survival strategies shift. As the sunfish grows from a larva into a juvenile, its rate of development becomes truly astounding, a spectacle of biological acceleration. From a few millimeters, it begins to rapidly increase in size, growing in both length and depth, its body slowly compressing laterally into the distinctive flattened disc. Its small, puckered mouth becomes more defined, ready for its specialized diet, and the clavus, that unique rudder-like appendage, begins to form at the posterior end of its body, replacing the ancestral caudal fin that has long since vanished. During this juvenile phase, often when the sunfish is still no larger than a dinner plate, it already exhibits many of the anatomical hallmarks of its adult form, albeit in miniature. The growth rate of the Mola is in many respects unparalleled in the animal kingdom. Scientists estimate that a juvenile sunfish can increase its weight by an astonishing factor of 60 million from its larval stage to adulthood. To put this into perspective, imagine a human baby growing to the size of an Olympic swimming pool in a matter of years. This rapid, almost explosive growth is crucial for escaping the gauntlet of small and medium-sized predators that prey on younger, smaller fish in the open ocean. The faster it grows, the sooner it reaches a size where only the largest and most formidable predators, such as orcas or large sharks, pose a significant threat. This phenomenal growth is fueled by its highly efficient, though seemingly low-calorie diet of gelatinous zooplankton, a testament to its specialized digestive system and low metabolic rate. As the juvenile sunfish continues its astonishing growth, it gradually adopts the deeper diving behaviors characteristic of the adults. No longer confined to the sunlit surface layers, it begins to explore the mesopelagic zone where its primary food sources often aggregate in vast dispersed blooms. Its skin thickens and toughens, developing the characteristic leathery texture, and its coloration shifts from a more uniform hue to the mottled silver-grey brown or white patterns that help it blend into the shifting light, and shadows of the open ocean. The enormous dorsal and anal fins, now fully developed, begin their slow rhythmic undulations, propelling the steadily growing giant through the water with an almost hypnotic grace. Reaching full maturity, a process that can take several years, an adult Mola is a truly magnificent sight, a colossal living millstone adrift in the vastness. It has survived the countless dangers of its early life, escaped the jaws of predators, weathered the storms of the ocean, and transformed from a microscopic spiny star into the heaviest, bony fish on Earth. At this stage, it possesses the full reproductive capacity to continue the cycle, to release its own prodigious bounty of eggs into the ocean, ensuring the perpetuation of its unique lineage. While the exact lifespan of an ocean sunfish in the wild is still largely a mystery, with estimates ranging from decades to perhaps even longer, their immense size and slow, deliberate movements suggest a creature built for longevity, a patient, enduring presence in the deep. The life cycle of the Mola is a profound narrative of adaptation, a testament to the power of natural selection to sculpt life into forms that are both bizarre and exquisitely functional. From the almost unimaginable number of eggs released into the open ocean through the vulnerable spiny larval stage, to the rapid, almost miraculous growth into a colossal adult. Each phase is a delicate balance of risk and reward, of vulnerability and resilience. It is a story whispered across the currents, a silent epic unfolding in the boundless blue, reminding us of the quiet wonders that begin with the smallest spark of life and culminate in the most magnificent of oceanic giants. As we allow these images of transformation to gently settle within our minds, we are left with a deeper appreciation for the intricate, often unseen processes that sustain life in the deepest, most mysterious parts of our world. Sunbathers and deep divers. The enigmatic behavior of Mola. As the echoes of its remarkable life cycle softly recede, our quiet contemplation now turns to the living, breathing rhythms of the ocean sunfish itself, to the enigmatic behaviors that define its existence within the vast blue world. Its days are a slow, deliberate oscillation between two profound extremes: the sun-drenched, shimmering surface where it engages in its iconic basking, and the frigid, abyssal depths where it silently hunts its ethereal prey. This dance between light and shadow, warmth and cold, is not merely a habit but a finely tuned survival strategy, a testament to the Mola's unique adaptation to the pelagic realm. Imagine, if you will, the serene spectacle of a Mola. At the ocean's surface, its colossal, flattened body turned gracefully on its side, often with its immense dorsal fin breaking the water, a dark triangular sail against the bright sky. This is the origin of its common name, the sunfish. A creature seemingly in communion with the very star that warms our planet. The act of basking is not a display of idleness, but a crucial physiological process, a slow, deliberate absorption of solar energy. As sunlight penetrates the upper layers of the water, its warmth permeates the sunfish's thick, leathery skin, slowly raising its core body temperature. This rewarming is absolutely vital, a restorative ritual after the profound chill of its deep-sea foraging excursions. Scientists theorize that the Mola relies on this surface thermoregulation to recover from the metabolic slowdown induced by prolonged exposure to cold, deep waters. Picture the immense internal landscape of the sunfish, its muscles and organs growing sluggish in the near-freezing temperatures of the abyss. Returning to the surface, it allows the sun's gentle embrace to slowly awaken its internal systems, to restore optimal function to its digestion, its circulation, and its muscular activity. It is a slow, patient recharging a biological imperative that fuels its continued existence in the highly variable thermal environments of the open ocean. Without these periods of sunlit recovery, the sunfish would quickly succumb to the debilitating effects of hypothermia, unable to effectively hunt or even propel its massive body. Beyond the vital function of thermoregulation, the act of basking is also believed to serve a crucial role in parasite removal. The rough, often scarred skin of the Mola is a veritable ecosystem for a diverse array of external parasites, from tiny copepods that cling tenaciously to its surface to larger, more visible trematodes that embed themselves within its thick integument. By lying exposed and vulnerable at the surface, the sunfish effectively invites a unique form of symbiotic assistance. Seabirds such as gulls, petrels, and shearwaters have been observed gently alighting upon the broad, flat back of a basking sunfish, meticulously pecking away at the parasites, providing a natural cleaning service. Imagine the delicate touch of a bird's beak against the rough skin of the immense fish, a silent cooperative exchange in the vastness of the ocean. In shallower, more coastal waters, sunfish have also been seen frequenting cleaner stations, specific locations where smaller, cleaner fish, like wrasse, will swarm over their bodies, diligently removing parasites from their skin gills and even their small, puckered mouths. These moments of quiet interaction underscore the intricate, often surprising connections within marine ecosystems. Yet, the Mola is not solely a creature of the sunlit surface. Its existence is defined equally by its profound connection to the depths, by its remarkable capacity for deep diving. These colossal fish undertake astonishing vertical migrations, plunging hundreds of meters, sometimes over 800 meters, into the cold, dark world of the mesopelagic and bathypelagic zones. Imagine the slow, deliberate descent, the gradual fading of light, as the vibrant blues of the surface give way to an ethereal indigo, then to a profound inky blackness, where the only illumination comes from the faint, bioluminescent flickers of deep-sea organisms. In these frigid, pressurized realms, the Mola seeks out the vast, often dispersed aggregations of its primary food sources, jellyfish, siphonophores, and salps, which tend to congregate at specific depths. These deep dives are not merely plunges into the unknown. They are purposeful foraging expeditions guided by an innate sense of where its gelatinous prey resides. The sunfish, with its unique propulsion system of undulating dorsal and anal fins, glides slowly, methodically through these depths, its small eyes scanning the dimness, its lateral line system subtly detecting the faint pressure waves generated by the slow pulsations of a jellyfish bell. It is a slow-motion hunt, a ballet of gentle detection and deliberate ingestion, where patience and persistence are the key tools. Its lack of a swim bladder, a gas-filled organ used by most bony fish for buoyancy control, is a distinct advantage here. Without a swim bladder to compress and decompress, the sunfish avoids the physiological stresses and energy expenditure associated with rapid pressure changes, allowing it to move effortlessly between the surface and the deep. Its unique tissue composition, particularly its jelly-like subcutaneous layer, which is less dense than seawater, provides inherent buoyancy, allowing it to maintain its position in the water column with minimal effort. The daily rhythm of the Mola's life is therefore a constant, slow, vertical migration, a silent pendulum swinging between the warmth of the sun and the chill of the abyss. Satellite tagging data have revealed that individual sunfish can perform multiple deep dives throughout the day, often spending significant periods at depth, meticulously sweeping through the water column. These patterns are often influenced by the time of day, with deeper, longer dives occurring during the daylight hours, perhaps to avoid surface predators, or to access deeper dwelling prey that might migrate vertically with the sun. The return to warmer surface waters is not just for rewarming, but also to aid in the digestion of its often low-nutrient, water-rich meals, as metabolic processes are more efficient at higher temperatures. In terms of locomotion, the Mola's behavior is a marvel of energy efficiency. Unlike the powerful tail-driven propulsion of most fish, the sunfish moves by simultaneously oscillating its immense dorsal and anal fins. Imagine these two colossal wing-like structures rising and falling in perfect opposition, creating a rhythmic sculling motion that propels the massive body forward with a quiet, persistent grace. It is a slow, elegant ballet, a continuous wave-like movement that allows the Mola to drift effortlessly through the vastness. Its small pectoral fins, almost vestigial, perform little more than subtle adjustments to its orientation, while the unique, rudder-like clavus provides stability and fine-tuned directional control. This specialized mode of propulsion, while not built for speed, is perfectly adapted for its energy-efficient long-distance drifts and its precise vertical movements through the water column. Despite its immense size, the Mola is generally considered a solitary creature, a lone wanderer of the open ocean. Its life is one of quiet independence, drifting across vast ocean basins driven by the search for food and optimal thermal conditions. However, there are instances where sunfish are observed in small aggregations, though these are often temporary and localized. Such gatherings might occur in areas of particularly abundant food, where a dense bloom of jellyfish attracts multiple individuals. They can also be seen congregating at cleaner stations near coastal reefs, patiently awaiting their turn to be rid of their parasites. While there is still much to learn about their reproductive behavior, it is believed that spawning occurs in the open ocean, with females releasing their millions of eggs into the water column, suggesting no direct parental care or complex courtship rituals are tied to fixed locations. Interaction with other marine life is generally passive. Its colossal size and tough, leathery skin offer a significant defense against most potential predators. Only the largest and most formidable oceanic hunters, such as killer whales, orcas, and great white sharks, are known to occasionally prey on Mola. Their encounters with humans are typically benign, with the sunfish often appearing curious yet unperturbed by the presence of divers or boats, slowly gliding away with an unhurried grace. The enigmatic behavior of the Mola. A constant interplay between the sun-drenched surface and the dark, cold abyss is a profound testament to its evolutionary success. It is a creature that has carved out a unique existence in the boundless blue, a slow-moving monument to adaptation, whose daily rhythms are a quiet, persistent echo of the ocean's own immense, unhurried pulse. As we allow these images of its deliberate dives and serene basking to gently settle within our minds, we are left with a deeper appreciation for the quiet ingenuity that allows this colossal yet gentle drifter to navigate the vast, ever-shifting liquid world. Giants and their shadows, predators and survival strategies. Even in the seemingly boundless tranquility of the open ocean where the sunfish drifts with such unhurried grace, the ancient silent drama of predator and prey unfolds with an unwavering certainty. For a creature of such immense proportions, one might assume a life largely free from threat, a colossal being, too formidable for any hunter. Yet even the ocean sunfish, this ponderous leviathan, casts a shadow that attracts the attention of the ocean's most powerful and discerning carnivores. Its survival, particularly through its vulnerable early stages and into its colossal adulthood, is a testament to a unique suite of passive defenses and an almost improbable resilience against the relentless forces of the deep. The primary predators capable of truly challenging an adult mola are few, but they are among the most formidable hunters on our planet. Foremost among them are the orcas, or killer whales, magnificent cetaceans whose intelligent strength and sophisticated hunting techniques place them at the apex of the marine food web. Imagine a pod of these sleek, black and white giants moving with synchronized purpose through the blue, their keen senses attuned to the subtle movements and sounds of the ocean. When an orcapod encounters an ocean sunfish, it is not merely a chance meeting, but often a deliberate, calculated engagement. Observations, though rare, describe a chillingly efficient method of attack. Orcas are known to harass the sunfish, pushing and bumping its immense flattened body, sometimes even lifting it partly out of the water before ultimately dismembering it. They seem to exhibit a particular preference for the sunfish's softer tissues, particularly its internal organs and muscle, leaving behind the tough, leathery skin and much of its cartilaginous skeleton. This selective feeding suggests that while the sunfish's bulk is impressive, certain parts are more palatable and energy-rich for these intelligent predators. The very spectacle of such a hunt underscores the raw power and strategic prowess of the orca, a creature that perceives even the 2-ton sunfish as a potential meal, albeit one that requires a unique approach. Another formidable shadow that occasionally falls upon the mola is that of the great white shark, a solitary hunter of immense power and ancient lineage. While great whites primarily target seals, sea lions, and other marine mammals, they are opportunistic predators, and a large, slow-moving mola can sometimes present an irresistible target. Envision the silent approach of a great white, a torpedo of muscle and teeth, materializing from the hazy depths its senses honed to detect the subtle vibrations and chemical cues of potential prey. A sunfish with its ponderous movements and lack of evasive speed would seem an easy target. However, its immense flattened and somewhat awkward disc-like shape can present a unique challenge even for a great white. The thick, tough skin and the high proportion of cartilage and water in its flesh might make it less appealing or harder to consume whole than other, more conventional prey. While evidence of great white predation on adult sunfish is less common than that of orcas, the scars sometimes observed on sunfish bodies, including large bite marks, silently attest to these dangerous encounters. Whispers of a struggle in the deep that the sunfish somehow managed to endure. For the younger, smaller sunfish, the spectrum of predators broadens considerably. In their larval and juvenile stages, when they are mere millimeters or centimeters in size, they face a myriad of threats from a vast array of opportunistic feeders. Tiny larval fish, small crustaceans, and even larger planktonic organisms can prey upon the microscopic sunfish larvae, those spiny star-like forms drifting helplessly in the planktonic soup. As they grow into dinner plate-sized juveniles, they become targets for larger predatory fish, such as tuna mahi-mahi, and various species of sharks that patrol the open ocean. Their sheer numbers, the release of hundreds of millions of eggs, is the species' primary strategy to overcome this immense early mortality, a biological gamble against overwhelming odds. The rapid growth rate that characterizes their juvenile phase is also a crucial survival mechanism, allowing them to quickly outgrow the size range of many potential predators, reaching a scale where only the ocean's true giants pose a significant threat. The primary survival strategy of the adult Mola is quite simply its immense size. Imagine a creature so vast, so ponderous, that its sheer bulk becomes a formidable deterrent. To swallow or even effectively incapacitate a 2-ton flattened disc of leathery flesh would be a monumental task for almost any predator. This colossal dimension, achieved through an astonishing growth rate fueled by its specialized diet, is its first and most potent line of defense. It is a silent, unmoving declaration of its unsuitability as a meal for all but the most powerful and determined hunters. Complementing its colossal size is its remarkably tough and leathery skin. Unlike the smooth, easily torn skin of many fish, the Mola's integument is thick, resilient, and often covered in a layer of mucus, sometimes even adorned with small, bony protuberances. Picture this skin, rough to the touch, almost like coarse sandpaper, offering a formidable barrier against the sharp teeth of a predator. It is not merely a superficial covering, but a robust armor, making it difficult for a predator to gain a firm purchase or to inflict a debilitating bite. This skin, often scarred from past encounters or from the abrasive forces of the ocean, silently tells a story of endurance, of countless challenges weathered and overcome. The unique flattened disc-like body shape of the Mola also serves as an unexpected defense. While it might appear awkward for propulsion, this extreme lateral compression makes it an incredibly difficult shape for a predator to grasp bite into or consume whole. Imagine a great white shark attempting to take a clean bite out of a creature shaped like a colossal living dinner plate. Its wide, flat profile, combined with its lack of a distinct neck or tail, offers no easy point of attack for a predator seeking to sever or incapacitate. It is a biological puzzle, an unwieldy meal that demands significant effort and specialized hunting techniques, making it less attractive than more conventionally shaped prey. Scientists also theorize, though this remains an area of ongoing research, that the Mola's flesh itself may offer a deterrent. Its diet of gelatinous zooplankton, largely composed of water, means its tissues are relatively low in nutritional density compared to other fish or marine mammals. Furthermore, its skeleton is largely cartilaginous and spongy, further reducing the calorific return for a predator expending significant energy in a hunt. Some researchers suggest that its flesh may also contain certain toxins or unpleasant compounds derived from its diet, making it less palatable. While not a consensus fact, it is a plausible hypothesis that its overall quality as a meal might not always justify the immense effort required to catch and consume it, especially for predators with more energy-rich alternatives. The Mola's enigmatic behavior, particularly its deep diving, also plays a crucial role in its survival. By undertaking prolonged descents into the frigid, abyssal depths, it effectively escapes the surface-dwelling predators that might pose a threat. The deep ocean, while not devoid of life, has a different suite of predators, and the sunfish's ability to seamlessly transition between the warm, sunlit surface and the cold, dark abyss allows it to utilize a vast, three-dimensional refuge. When it basks at the surface, it is often in open waters far from coastal ambushes, further reducing the risk of encountering predators that might lurk in more structured environments. Its pelagic lifestyle, drifting across vast ocean basins, also contributes to its survival by making it a dispersed and often solitary target, harder for localized predators to consistently find and track. It is important to note that the Mola does not possess active defenses in the traditional sense. It does not bite, sting, or flee with bursts of speed. Its survival strategy is almost entirely passive, relying on its colossal size, its robust physical attributes, and its unique patterns of movement and habitat utilization. When confronted by a predator, its primary response is often to attempt to dive or to simply drift away with its slow, undulating fins, relying on its sheer bulk and awkward shape to deter further aggression. This quiet, non-confrontational approach is a hallmark of its existence, a testament to a species that has found its niche not through aggression or speed, but through an almost serene resilience. In essence, the Mola is a living fortress not through impenetrable armor or formidable weaponry, but through a clever combination of scale, texture, and an almost philosophical acceptance of its place in the food web. Its journey from a microscopic spiny star to an oceanic giant is a story punctuated by countless perils. Yet its very existence, its continued presence in the world's oceans, speaks to the profound success of its unique survival strategies. As we allow these images of its quiet endurance to settle softly in our minds, we are reminded that even the most vulnerable of beginnings can lead to the most magnificent and resilient of lives, drifting ponderously beneath the vast, silent shadows of the deep. Whispers from the deep, unraveling the sunfish's secrets, as the quiet echoes of its survival strategies softly fade. Our minds now gently turn to the patient, persistent efforts of those who seek to understand the Mola. To the dedicated individuals who listen for the whispers from the deep, slowly, meticulously unraveling the myriad secrets held within its immense, enigmatic form. For a creature that spends its life drifting across vast, open oceans, undertaking profound vertical migrations from sunlit surface to frigid abyss, the ocean sunfish presents a formidable challenge to scientific inquiry. Its pelagic nature, its often solitary existence, and the sheer scale of its habitat mean that direct observation is a rare and fleeting gift, making the task of understanding its biology and behavior akin to piecing together a cosmic puzzle from scattered delicate fragments. For many years, our understanding of the Mola was largely confined to observations of stranded individuals, those immense, often bewildered giants washed ashore by the relentless currents, their life journeys tragically concluded. These somber events, while heartbreaking, offered invaluable opportunities for scientists to examine their colossal anatomy, to study their unique skeletal structure, to analyze the contents of their stomachs, and to glean insights into their diet and parasitic burdens. Imagine the quiet dedication of researchers meticulously measuring, weighing, and dissecting these immense specimens, each observation a precious data point, slowly building a foundational knowledge of this mysterious fish. Similarly, incidental catches in commercial fishing gear, particularly long lines and drift nets, have also provided opportunities for study, though these encounters underscore the very threats facing these magnificent creatures. Each specimen, whether stranded or caught, became a silent messenger from the deep, carrying clues about its life in the boundless blue. However, the true revolution in understanding the Mola's hidden life has come with the advent of advanced tracking technologies, allowing scientists to follow these elusive giants in their own element without direct human presence. Foremost among these tools are satellite tagging devices, small, robust instruments carefully attached to the sunfish's dorsal fin. These tags, often referred to as pop-up archival tags, or PATs, are technological marvels. Imagine a tiny, intelligent device no larger than a soda can, meticulously programmed to record a wealth of environmental data, the precise depth of the fish, the temperature of the water it inhabits, and even the ambient light levels it experiences throughout its journey. For a predetermined period, often several months, this tag silently collects data, storing it within its internal memory as the sunfish drifts across thousands of kilometers. When its mission is complete, or if the sunfish dives beyond a certain depth, the tag is designed to detach itself from the fish, floating gently to the surface. Once it breaches the waves, a small transmitter within the tag activates, beaming its precious cargo of recorded data upwards through the vastness of space to orbiting satellites. These satellites then relay the information back to waiting researchers on Earth, unveiling the intricate three-dimensional journey of the sunfish. Picture the quiet anticipation of scientists poring over the incoming data, watching as lines on a map begin to trace the immense meandering paths of these oceanic wanderers, seeing the subtle undulations on a depth graph that reveal their daily ascent and descent. These satellite tags have been instrumental in confirming and quantifying many long-held theories about the Mola. They have provided undeniable evidence of their profound vertical migrations, showing how sunfish repeatedly plunge hundreds of meters into the frigid abyss, often spending significant periods at depth before slowly returning to the warmer surface waters. This data has solidified the understanding that these deep dives are primarily for foraging on gelatinous prey, while the surface basking is crucial for re-warming their immense bodies, a vital act of thermoregulation after the metabolic slowdown induced by cold. The tags have also revealed the astonishing horizontal distances these fish cover, often drifting passively with the great oceanic currents for thousands of kilometers. Their movements dictated by the subtle shifts in water temperature and the availability of their dispersed food sources. These silent electronic whispers from the deep have transformed our understanding of their global distribution and their unhurried yet immense migratory patterns. Beyond satellite tags, other sophisticated tools are slowly coaxing more secrets from the deep. Acoustic telemetry, though more localized, involves attaching transmitters that emit unique sound signals, allowing researchers using hydrophones to track individual sunfish within a defined area. This method provides fine-scale data on their movements and interactions within a specific habitat, offering glimpses into their more immediate behaviors. Underwater cameras deployed on remotely operated vehicles, ROVs, or even by patient divers, occasionally capture rare, fleeting moments of Mola in their natural environment, revealing subtle nuances of their propulsion feeding and interactions with other marine life. Imagine the quiet thrill of seeing one of these immense creatures drift past the lens, a silent, living sculpture in its boundless home. Genomic analysis represents another powerful frontier in sunfish research. By analyzing the DNA of Mola, specimens, scientists can unravel the intricate genetic relationships between different populations, revealing patterns of gene flow across ocean basins and providing deeper insights into their evolutionary history. This genetic detective work has already yielded remarkable discoveries, such as the identification of previously unrecognized Mola species, like the hoodwinker sunfish, Mola tecta, which was only formally described in 2017 after decades of being overlooked. This quiet revelation underscored how much more there is to learn even about such a visually distinctive creature. Genomic studies also hold the promise of uncovering the genetic basis for their unique adaptations, such as their extreme growth rate, their specialized diet, and their unusual skeletal structure. Another technique, stable isotope analysis, offers a window into the sunfish's dietary history over longer periods. By examining the ratios of stable isotopes of carbon and nitrogen in their tissues, scientists can infer their long-term diet, providing a more comprehensive picture of what they consume beyond what is found in a single stomach content analysis. This method helps to confirm the dominance of gelatinous zooplankton in their diet and can also reveal regional variations in their feeding habits, depending on the availability of different prey types. Despite these remarkable advancements, many profound mysteries surrounding the Mola continue to persist, like faint echoes from the deepest parts of the ocean. Their precise reproductive behaviors, for instance, remain largely unobserved. While we know they release hundreds of millions of eggs, the exact locations of their spawning grounds, the intricate details of their courtship rituals, if any, and the environmental cues that trigger this colossal act of reproduction are still largely unknown. Imagine the challenge of finding such an event in the vastness of the open ocean, a needle in an oceanic haystack. Similarly, their exact lifespan in the wild is still a matter of scientific estimation, with varying theories suggesting a longevity that could span several decades, a testament to their slow, deliberate existence. The true population numbers and the overall health of Mola populations across the globe also remain elusive. Their wide distribution, coupled with their pelagic nature, makes accurate census taking incredibly difficult. Are their numbers stable, increasing, or subtly declining in response to human pressures? These are critical questions that require continued extensive research. Furthermore, the full extent of their ecological role, particularly their impact on jellyfish populations, is still being quantified. How significant are they as predators in regulating these gelatinous blooms? And what implications might changes in their populations have for the wider marine ecosystem? Even the very essence of their peculiar form continues to provoke quiet contemplation. Why this precise, truncated shape? While we understand many of its adaptive benefits, the intricate evolutionary pathways and the specific selective pressures that led to such an extreme departure from typical fish morphology still hold layers of intrigue. And what of their cognitive abilities? With a brain that is remarkably small in proportion to its immense body, the Mola challenges our assumptions about intelligence and survival. Is its existence driven purely by instinct? Or are there subtle, unobserved forms of awareness and learning at play within its colossal frame? The ongoing quest to unravel the Mola's secrets is a testament to the enduring human spirit of curiosity, a patient scientific endeavor that spans continents and generations. Each new technological advancement, each carefully analyzed piece of data, each fleeting observation slowly adds another brushstroke to the grand portrait of this magnificent creature. It is a journey of discovery that relies on international collaboration, on shared knowledge, and on the quiet dedication of researchers who are drawn to the profound allure of the unknown. As we allow these scientific whispers from the deep to gently resonate within our minds, we are reminded that the ocean still holds countless wonders, waiting patiently for us to listen, to observe, and to understand, inviting us to delve deeper into its profound and silent mysteries. Navigating troubled waters, conservation challenges, and human impact. As the quiet whispers from the deep gently guide us through the scientific unraveling of the sunfish's mysteries, a new, more somber current begins to stir in our narrative, one that reflects the profound and often troubling impact of humanity on the ocean's delicate balance. Even the colossal enigmatic Mola, a creature that has drifted through deep time with such resilient grace, finds its existence increasingly intertwined with and sometimes threatened by the pervasive reach of human activity. Navigating these troubled waters, understanding the conservation challenges facing the ocean sunfish, is a crucial step towards ensuring its continued presence in the boundless blue. One of the most significant and widespread threats to the Mola stems from its unfortunate susceptibility to being caught as bycatch in commercial fishing operations. Imagine vast invisible walls of netting, sometimes stretching for many kilometers, deployed across the open ocean to target schools of tuna swordfish or other commercially valuable species. Or picture long lines trailing thousands of baited hooks through the water column, patiently waiting for a bite. The Mola, with its immense flattened body and ponderous movements, is simply not built to detect or evade these passive yet deadly fishing gears. As it drifts through the pelagic zone seeking its gelatinous prey, it can easily become entangled in gill nets or inadvertently hooked on long lines. Once caught, the sheer size and awkward shape of the sunfish often make it difficult, if not impossible, for fishing crews to safely release it back into the ocean. Its rough skin can become deeply entangled in netting, and its immense weight makes it challenging to lift and maneuver. Even if released individuals that have been severely stressed, injured, or dragged for extended periods may not survive. The scale of this bycatch is difficult to quantify precisely given the vastness of the oceans and the pelagic nature of the sunfish, but scientists believe it represents a significant source of mortality across its global distribution. In some regions, bycatch rates of Mola can be alarmingly high, reflecting a tragic unintended consequence of industrial fishing practices. This silent, often unseen attrition slowly, persistently chips away at sunfish populations, a constant drain on their numbers. Beyond direct bycatch, the broader impacts of fishing on the marine food web can also indirectly affect the Mola. While its primary diet consists of jellyfish and sulps, which are not directly targeted by fisheries disruptions, to the wider pelagic ecosystem can have unforeseen consequences. Changes in the abundance of other planktonic organisms or shifts in the populations of other predators and competitors could subtly alter the availability of its preferred prey or the overall health of its habitat. The ocean is an intricately balanced system, and disturbance in one area can ripple outwards, affecting even the most specialized of creatures. Plastic pollution, a pervasive and ever-growing global crisis, poses another insidious threat to the ocean sunfish. Imagine the vast, swirling gyres of plastic debris that accumulate in the open ocean, immense patches of discarded bags, bottles, and microplastics slowly breaking down into smaller and smaller fragments. The Mola, with its specialized diet of gelatinous organisms, is particularly vulnerable to mistaking plastic bags or other translucent plastic debris for its natural prey. Picture a sunfish slowly drawing in what it perceives to be a large jellyfish, only to ingest a non-digestible piece of plastic. This ingestion can lead to blockages in its digestive system, causing internal injuries, malnutrition, and ultimately starvation. The sheer volume of plastic now saturating our oceans means that these accidental ingestions are becoming an increasingly common and deadly threat to filter feeders and specialized jellyfish predators, like the sunfish. Climate change, with its profound and far-reaching effects on global ocean systems, introduces a complex layer of challenges for the Mola. As ocean temperatures slowly rise, and as ocean currents subtly shift the distribution of the sunfish's preferred prey, the jellyfish and sulps may also change. Imagine vast aggregations of these gelatinous organisms moving into new areas or declining in others, compelling the sunfish to embark on longer, more energy-intensive migrations in search of food. Furthermore, the Mola is highly sensitive to cold water, with prolonged exposure to temperatures below a certain threshold, proving lethal. While warming oceans might seem beneficial in some respects, rapid and unpredictable changes in ocean circulation patterns leading to sudden upwellings of cold water or shifts in thermal boundaries, could expose sunfish to dangerously cold conditions, pushing them beyond their physiological limits. The increasing frequency and intensity of marine heat waves, too, could disrupt their delicate thermoregulation strategies, impacting their ability to recover from deep dives. Ocean acidification, another direct consequence of increased atmospheric carbon dioxide, also casts a long shadow. As the oceans absorb more CO2, their pH slowly decreases, making them more acidic. While the direct impact on Mola is not yet fully understood, ocean acidification can have profound effects on the entire marine food web, particularly on organisms that build shells, or skeletons such as pteropods, which are tiny shelled sea snails that form a crucial link in many pelagic food chains. Disruptions to these foundational species could have cascading effects, potentially impacting the wider availability of planktonic food sources for the sunfish and its prey. The very mystery surrounding the Mola's life cycle and population dynamics also presents a conservation challenge. Without accurate data on their global population numbers, their reproductive rates, and the specific threats impacting different regional populations, it becomes incredibly difficult to implement effective conservation measures. How can we protect a species if we do not fully understand the scale of its decline or the most critical pressure points in its life? This lack of comprehensive data underscores the urgent need for continued scientific research, for more extensive tagging studies, and for international cooperation to monitor and assess the health of sunfish populations worldwide. Despite these growing pressures, the Mola is currently listed as vulnerable by the International Union for Conservation of Nature, IUCN, indicating that it faces a high risk of extinction in the wild. This classification serves as a crucial warning, a call to action for conservation efforts. Protecting these magnificent creatures requires a multifaceted approach. Reducing bycatch in commercial fisheries through the implementation of more selective fishing gear, the use of deterrents or the establishment of seasonal closures in areas of high sunfish aggregation is paramount. Educating fishermen and promoting best practices for the safe release of incidentally caught sunfish can also make a significant difference. Beyond fishing practices, addressing the global crisis of plastic pollution through both prevention and cleanup initiatives is vital for the survival of the Mola and countless other marine species. Supporting policies that mitigate climate change and reduce carbon emissions is also crucial, as the long-term health of the oceans and all its inhabitants depends on a stable climate. Furthermore, continued funding and support for scientific research are essential to fill the remaining knowledge gaps, allowing conservationists to make informed decisions and to develop more targeted and effective protection strategies. The Mola. This colossal gentle drifter is a living testament to the boundless creativity of evolution, a creature that has navigated the immense challenges of deep time with quiet resilience. Its continued presence in our oceans is a reflection not only of its own remarkable adaptability, but also of the health and vitality of the pelagic ecosystem. To lose such a unique and magnificent being would be a profound loss, a silent diminishment of the wonder and diversity that defines our planet. As we allow these somber reflections to gently settle within our minds, we are compelled to acknowledge our shared responsibility to listen more closely to the whispers from the deep and to navigate these troubled waters with greater care, ensuring that the ocean sunfish can continue its slow, majestic journey across the blue expanse for countless generations to come. The sunfish in human lore. Perceptions and misconceptions. As the somber currents of conservation challenges gently recede, Our quiet contemplation now turns to the profound and often curious relationship between humanity and the ocean sunfish, to the rich and sometimes contradictory perceptions that have woven themselves around this enigmatic creature throughout history. For centuries, the peculiar visage of the Mola has stirred a quiet, sometimes bewildered curiosity in the human observer, leading to a rich collection of understandings, some imbued with profound awe, others with a subtle thread of misunderstanding. Imagine a time before scientific expeditions, before deep-sea cameras and satellite tags, when a colossal disc-shaped fish, seemingly without a tail, would suddenly materialize from the vast open ocean, its immense dorsal fin slicing through the surface like a strange, unfamiliar sail. For early mariners, for coastal communities whose lives were intimately intertwined with the sea, such an encounter must have evoked a complex mixture of wonder, bewilderment, and perhaps even a primal, respectful awe. This was a creature unlike any other, a living anomaly that defied easy categorization, a silent, ponderous giant that seemed to emerge from the very edge of the known world. Its sheer size alone would have marked it as a being of significance, a quiet leviathan in a world where the unknown still held vast sway. The various names bestowed upon the Mola across different cultures and languages offer a fascinating glimpse into these diverse human perceptions. The very name, Mola, whispered in scientific circles, finds its roots in the Latin word for millstone, an ancient, weighty implement of grinding perfectly, capturing its massive rounded and often textured form. Imagine the early naturalists perhaps encountering a stranded specimen, its immense grey disc, resembling a piece of ancient weathered stone pulled from the depths of the earth rather than born of the sea. This name speaks to its physical presence, its undeniable solidity and colossal weight. In other languages, the names reflect its peculiar morphology. In German, it is often called mondfish or moonfish, a poetic descriptor that evokes its round, pale, and often luminous appearance as it drifts through the water, reminiscent of a full moon suspended in the night sky. Or perhaps schwimmender Kopf, meaning swimming head. A strikingly accurate, if somewhat whimsical description of a creature that truly appears to be little more than a gigantic head propelled by its vertical fins. Similarly, the English Ocean Sunfish directly references its distinctive behavior of basking on its side near the surface, absorbing the sun's gentle warmth, a behavior that must have seemed both serene and utterly unique to those who witnessed it. In Spanish, it is pez luna, again moonfish, echoing the German perception. These names, born of observation and poetic imagination, reveal a consistent human effort to grasp and describe the Mola's most striking features, often with a sense of wonder at its profound difference. Yet alongside these admiring descriptions, misconceptions have also quietly settled around the Mola, often stemming from its unusual appearance and its slow, deliberate movements. One of the most enduring misconceptions is the notion of its inherent clumsiness, a creature often perceived as an awkward, inefficient swimmer, almost an evolutionary oversight. Its slow, undulating propulsion, so distinct from the powerful tail beats of more familiar streamlined fish, has often been interpreted as a sign of biological inadequacy, leading to a popular image of the sunfish as a somewhat dumb or useless inhabitant of the ocean. This perception, often amplified in casual commentary, and even some popular media, overlooks the profound elegance of its specialized adaptation. Scientists, through patient observation and meticulous research, understand that the Mola's slow rhythmic movement is not a sign of clumsiness, but rather a highly energy-efficient mode of locomotion. Its immense wing-like dorsal and anal fins, undulating in perfect synchronicity, propel its massive body with a continuous low-energy grace, perfectly adapted for drifting across vast ocean basins in search of widely dispersed low-calorie prey. It is not built for speed, for it has no need for it. Its survival strategy relies on persistence, not pursuit. This perceived clumsiness is in reality a marvel of evolutionary design, a testament to efficiency in a challenging environment, transforming what appears to be a flaw into a profound biological advantage. Another misconception often revolves around the Mola's diet and apparent lack of purpose. How could such a colossal creature survive, let alone thrive on a diet of jellyfish organisms perceived as largely insubstantial and nutritionally poor? This puzzle has sometimes led to the idea that the sunfish is an evolutionary mistake, a creature that somehow ended up with a body ill-suited for its environment. Yet, as we have softly explored its specialized mouth and digestive system, are exquisitely refined tools for consuming vast quantities of gelatinous zooplankton. Its low metabolic rate and buoyant tissues allow it to sustain its immense size on this diet, demonstrating a profound ecological specialization rather than a biological blunder. The Mola fills a vital niche in the pelagic food web, consuming jellyfish and salps that few other large predators target, thereby playing a quiet yet significant role in regulating these populations. Its purpose is clear, though perhaps not immediately obvious to our human-centric understanding of efficiency and utility. In terms of danger or threat, the Mola has generally been perceived as benign, even gentle. Unlike large sharks or venomous marine creatures, the sunfish poses no active threat to humans. Its small, puckered mouth and placid demeanor ensure that encounters with divers or swimmers are typically peaceful, often marked by the sunfish's curious, unhurried observation of its human visitors before slowly drifting away. Any initial fear or apprehension arising from its sheer size and unfamiliar form quickly gives way to wonder upon closer observation. Divers often describe encounters with Mola as deeply moving experiences. A quiet communion with one of the ocean's most unique inhabitants, its presence radiating a serene, almost ancient calm. In the modern era, amplified by the swift currents of digital communication and social media, the Mola's unique appearance has at times become a subject of light-hearted jest, even affectionate ridicule. It has found its way into popular culture, sometimes depicted as an almost comical figure, its seemingly vacant expression and truncated form lending itself to caricatures of a clumsy or simple creature. Memes and online discussions sometimes refer to it as the dumbest fish or the ugliest fish. Playful labels that reflect a superficial appreciation of its unusualness. Yet beneath these surface observations, these moments of digital amusement, lies a profound biological success story, a testament to an intelligence not necessarily in the human sense of complex problem-solving, but in the exquisite functionality of its ancient design, honed over millions of years. This modern fascination, even in its humorous forms, has inadvertently contributed to a greater public awareness of the Mola. Its bizarre nature has made it memorable, sparking curiosity in a wider audience that might otherwise remain unaware of its existence. This increased visibility, though sometimes playful, can be a valuable starting point for conservation efforts, transforming casual interest into a deeper appreciation and a willingness to support protective measures. The very strangeness that makes it a subject of online jest also makes it a powerful ambassador for the wonders of marine biodiversity, a living invitation to look beyond the familiar and embrace the extraordinary. Ultimately, the story of the Mola in human lore is a story of our own evolving understanding, a journey from initial bewilderment and poetic naming to scientific inquiry, and increasingly to a deeper, more nuanced appreciation. It reminds us that what appears bizarre or awkward through the lens of our own human perceptions is often, in the grand theatre of evolution, a masterpiece of specialized adaptation, a perfect solution to a unique set of environmental challenges. The sunfish, with its immense flattened form, its slow, deliberate movements, and its seemingly improbable diet, is not an evolutionary anomaly to be dismissed, but a living testament to the boundless creativity of life itself. A quiet declaration that beauty and success can manifest in the most unexpected and profoundly unique ways. As we allow these shifting perceptions to gently settle within our minds, we are encouraged to look beyond the superficial, to seek the deeper truths embedded within the quiet, enigmatic presence of this colossal drifter, forever challenging our preconceptions of what a fish should be. The enduring mystery, a gentle drift into the unknown. As the intricate layers of its anatomy, its ancient evolutionary journey, its specialized foraging, and its unique behaviors have softly unfolded before us, we might feel a sense of having journeyed deeply into the world of the ocean sunfish. We have traced its path from a microscopic spiny star to a colossal 2-ton drifter, understood its dance between sunlit surface and frigid abyss, and acknowledged the growing shadows of human impact. Yet for all that we have meticulously gathered, for every secret coaxed from the deep by patient science, the Mola remains at its very core an enduring mystery, a profound testament to the vast, uncharted realms that still lie beneath the ocean's shimmering surface. It is a creature that continually whispers new questions into the currents, inviting us to contemplate the boundless unknown. Many of the most fundamental aspects of the Mola's life remain tantalizingly out of reach, hidden within the immensity of its habitat. Consider, for instance, the profound act of its reproduction. We know with a quiet certainty that a female sunfish releases an astounding 300 million eggs, a prodigious biological feat, unmatched by any other vertebrate. But where precisely does this monumental spawning occur? Imagine trying to locate such an event in the vast, featureless expanse of the open ocean, a fleeting moment of biological creation in a liquid world without landmarks. Are there specific favored spawning grounds, perhaps areas with particular current patterns or nutrient upwellings that offer the nascent eggs and larvae the best chance of survival? Or does it occur opportunistically wherever two solitary giants happen to meet in the boundless blue? And how do these immense, often solitary individuals find each other in the vastness, initiating the intricate dance of procreation? The specifics of their courtship, if any, and the environmental cues that trigger this colossal release of life remain largely unobserved, a profound silent secret held by the deep. Even the delicate journey of its earliest life stages beyond the initial spiny larval form is shrouded in enigma. We have seen how the microscopic star-like larvae begin to transform, shedding their protective spines as they grow. But what are the precise environmental conditions that favor their survival? What are their specific feeding strategies as they navigate the perilous planktonic world, slowly growing from pinhead to dinner plate size? The mortality rate for these tiny beings must be astronomical. Yet the mechanisms that allow even a fraction to survive and embark on their incredible growth spurt are still being deciphered. It is a quiet struggle for existence unfolding in countless, unseen dramas beneath the waves, a testament to the immense odds against which life persists. Then there is the question of its lifespan, a profound aspect of any creature's existence. While its immense size and slow, deliberate movements suggest a potential for longevity, the precise lifespan of an ocean sunfish in the wild remains largely a matter of scientific estimation. How many decades do these gentle giants truly drift through the currents? What factors influence their growth rates, their age at maturity, and their ultimate longevity across different ocean basins? Are there ancient individuals bearing the scars of countless years that have traversed entire oceans, silently witnessing the slow march of time? Without the ability to reliably age wild individuals or to track them for their entire natural lives, these questions persist, echoing softly in the vastness of our knowledge gaps. The population dynamics of the Mola also remain a complex, elusive puzzle. Despite its global distribution, obtaining accurate global population estimates is incredibly challenging. How many sunfish truly inhabit the world's oceans? Are there distinct, genetically isolated populations, or is there a continuous interbreeding network across ocean basins? Are their numbers stable, increasing, or subtly declining in response to the growing pressures of bycatch plastic pollution and climate change? These are not mere academic questions, but vital inquiries for effective conservation. Without a clear understanding of their population structure and overall health, crafting targeted and impactful protection strategies becomes a far more difficult task, a quiet race against the unknown. Even their immense, almost effortless movements across the ocean continue to hold subtle layers of mystery. While satellite tags reveal the astonishing distances they cover, drifting thousands of kilometers, the precise triggers and motivations for these large-scale migrations are still being unraveled. Are they simply passive drifters carried entirely by the ocean's currents, making only subtle adjustments to their course? Or are there more active directional migrations guided by unseen forces, perhaps following specific thermal fronts or ephemeral aggregations of their gelatinous prey that stretch across entire ocean basins? Scientists believe it is a complex interplay, a delicate balance between passive drift and subtle, purposeful navigation. But the precise weights of these influences remain a subject of ongoing, quiet inquiry. And what of the Mola's internal world, its sensory experience of the vast ocean? With a brain that is remarkably small in proportion to its colossal body, how does it process its environment? What is the full extent of its sensory capabilities? How does its lateral line system, its small eyes, and its other senses integrate to allow it to navigate, find food, and detect predators in the profound darkness of the deep? Is there a form of intelligence, perhaps, one far removed from our own human understanding, that guides its slow, deliberate existence? These are questions that delve into the very essence of consciousness and perception in a creature so profoundly different from ourselves, inviting a deep, humble contemplation of the myriad ways life can experience its world. The Mola therefore stands as a living testament to the enduring mystery of the ocean itself. It is a creature that embodies the vastness of what we do not yet comprehend, a silent, ponderous reminder that despite our technological advancements and our ceaseless quest for knowledge, the deep blue still holds countless secrets waiting patiently to be discovered. Each new piece of research, each gentle whisper from the deep, only serves to deepen our appreciation for the profound complexity and the exquisite strangeness of life on Earth. The ocean sunfish, in its quiet, magnificent eccentricity, continues to challenge our perceptions, to expand our sense of wonder, and to invite us into a gentle, endless drift into the unknown. A journey that has no true end, only new horizons of discovery. Good night. See you again.